Be strong.
Hi everyone, welcome to my YouTube channel. So we are going to discuss on quantum physics about quantum effect. So what is quantum effect? So refer to this diagram. Okay, so this is a incident photon, a high energy photon, okay, colliding with a target here. So the target is the electron at rest. Okay, so the incident photon has the wavelength, initial wavelength lambda I. So after it hit the electron here, okay, so the recoiled electron is released. Okay, releases loosely bound electrons from the outer shell of the atom or molecule from the target atom here. And then also the Compton effect results in a decrease in the energy of the photon. Okay, means that increase in wavelength. Okay, decrease in energy or increase in wavelength. So the formula given, we are not going to discuss on derivation of the Compton effect formula here. Okay, so this is the formula. Initial final wavelength minus initial wavelength. So this is change in wavelength equals to h per m naught c bracket 1 minus cos theta. Okay, part of the energy of the photon is transferred to the recoiling electron. Here, the recoiling electron. So the wavelength of final wavelength larger than the initial wavelength. Okay, so the Compton effect or Compton scattering is the term given to what happens to the energy of a photon, like an X-ray or gamma ray, when it interacts with matter, primarily electrons. When this happens, its wavelength increases or energy or frequency decreases as it scatters off a target electron. Okay, like this animation. Example here, the gamma ray hit the target here, and and this is the gamma ray, scattered gamma ray, and this is the recoiling electron. Okay, so the Compton effect was observed by Arthur Holly Compton in 1923. Okay, so for his findings, Compton was awarded the 1927 Nobel Prize for Physics. So in 1923, Arthur H. Compton did experiments on bouncing X-rays of the electrons in graphite atoms. So Compton found the X-rays that scattered off the electron had a lower frequency and longer wavelength than they had before striking the electrons. The amount of the frequency changes depends on the scattering angles, the angle that the X-ray is deflected from its original path. So the Compton's experimental setup can be done in the lab, like here, the diagram given. So a beam of X-rays of wavelength 71.1 pm is directed onto a carbon target T, and the X-rays scattered from the target are observed at various angle theta to the direction of the incident beam. So the detector measures both the intensity of the scattered X-rays and their wavelength. So here is the detector, can be connected to the laptop to do the further analysis. So analogy to Compton effect. A great analogy is a game of pool. Imagine a table with just a cue ball, and the 8 ball. So if you strike the cue ball at the 8 ball, which was at rest, so the cue ball will hit it and deflect or scatter at some angle. So it will also lose some of its initial momentum and kinetic energy. So this is very similar to what happens when an X-ray photon hits and scatters off an electron. Okay. So what is the difference between Compton effect and photoelectric effect? So in photoelectric effect, involve a low energy phenomenon, whereas Compton effect, it involves a mid energy phenomenon. In photoelectric effect, photon delivers its total amount of energy to a single electron, whereas in Compton effect, the photon transfers part of its energy to a single electron. Okay, in photoelectric effect, it was explained by Albert Einstein, whereas the Compton effect was explained by Arthur Compton. And lastly, the difference is the photon disappears after the interaction in photoelectric effect, whereas in Compton effect, the wavelength of the scattered photon is higher than that of the incident photon. So what does the Compton effect prove? The Compton's work effectively provided additional spotting evidence for Einstein's solution of the photoelectric effect. Within this effect, Einstein postulated that light can occur as discrete particles rather than waves that could be used to theoretically produce electricity. This effect is the basic underpinning of how modern solar cells work. But when it was proposed in 1905, it really needed some experimental evidence to confirm the theory. So Compton's work provided this and showed that photons do indeed exhibit some particle-like behavior. So for his findings, Compton was awarded the 1927 Nobel Prize for Physics. Since then, many thousands of other experiments have since shown that light can exhibit both wave and particle behavior, a property called wave-particle duality. So it has since become one of the cornerstones of quantum mechanics. So application of Compton effect, it is used in astronomy to detect violent events in distant galaxies, and also used in radiobiology as it is the most probable interaction of gamma ray and high energy X-ray with atoms in living beings, and it applied in radiation therapy. Compton effect in astronomy, example here is the Imaging Compton Telescope. Okay, COMTEL utilizes the Compton effect and two layers of gamma ray detectors to reconstruct an image of a gamma ray source in the energy range 1 to 30 million electron volts. Okay, so that's all for the Compton effect. Thank you for watching.